Hello, and welcome to this presentation on contemporary service, explainable artificial intelligence as the modern facilitator. This is a presentation for CSE 545 at University of Louisville. My name is Michael Telehoon. So to start, the topics that are being covered here are mostly the relationship of explainable AI and its role in society as far as services go. Um, there will be an example with artificial intelligence in healthcare, specifically the three topics radiology, cardiology, and healthcare systems. Um, Briefly talk about how AI is a service provider and if it's capable of being responsible, or rather, if AI is capable of being used responsibly, where we're going, and then wrap up with some conclusions. So, briefly here, these are some of the main um, takeaways or main players in the game of artificial intelligence. We have robotics, we have expert systems, we have game theory. This is not just related to checkers or chess or games like this, but also 3D games. We have recommender systems. Some of these you might see in like Netflix or Spotify. IoT and sensor technology. We have speech and language processing. Many people have experienced Siri or Bixby or Amazon's Alexa. And we also have computer vision, which is becoming a very hot topic these days. So, in general, these areas of AI, they're all very interesting. They're all very on the cusp of what many people are trying to do nowadays. But uh, I guess one challenge I would ask the audience is to consider if all of these things are explainable, and if so, what pieces are and what pieces aren't. So to get started with the topic of explainable AI, we have the main challenges behind it. And kind of in brief, we have the main questions driving the topic are what's going on, what is the AI doing, why did it succeed, and why did it fail. So you can see these in the bottom right of the image. This image comes from the DARPA presentation on explainable artificial intelligence from 2018. And the problem statement kind of starts with the fact that artificial intelligence is seen as a black box often in enterprises. And they're not wrong about that, because often there's a lot that is left to be understood that either the developers, engineers could learn more about, and especially the users. Um, Users, shareholders, and now even more importantly, government entities are becoming more interested with the explainability of our intelligence systems. More and more often, we're seeing uh, organizations and hearings being publicly performed about in relation to how organizations are making their incomes, how artificial intelligence is playing a role in their incomes, and what steps they're providing to ensure security and no foul play when using artificial intelligence in their systems. Um, there's also the issue of performance um, that is often spoken about when we come to the challenges of explainable AI. This comes in the form of performance in terms of accuracy or quality of your model. Sometimes there may be a need for reduction in accuracy, which is a big no-no in the general sense of trying to get the best model to predict um, you know if an insurance claim is fraudulent, or if a robot can play basketball. You want all of those numbers to be as high as possible or as low as possible, depending on the metric. And reducing this may be beneficial in terms of making AI more explainable. but what this leads to is the ability for systems where we're using machine learning or we're using some complex model to become more transparent, and that is the overall goal. So that when we're as engineers promoting and integrating these systems with artificial intelligence, they're adopted with open hands, and everyone is more aware. So again, the issues here are why did the model do what it did? Why did it not do something else? How did it succeed in doing what it did? Or why did it fail in doing what it did? How do we know that it caused an error, or what are we going to do if it did cause an error? So this leads into what is the goal of AI, and it's or explainable AI, and that's pretty. It follows pretty simply from um, the issues, and that is to answer all of those questions. Why did the model do what it did? Well, a user should be able to understand these things. Why did it fail when it did? A user should also be able to understand that. What am I supposed to do when it errors? A user should also be presented with the option to handle that. And in the DARPA presentation for explainable artificial intelligence, this is kind of broken into three different steps. The first being breaking down these models or simplifying models that are very convoluted or very deep in nature, to using maybe simplified methods, or using maybe less information overall. Second, is there a possibility that we can create a interface that's intelligent, that's addresses all of the needs of the user, has diagnostic capabilities, is clear in language, is clear in explanation. It has all of the details that a user may need, and 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 aside from that, it has a continuous integration. When these things are deployed, often it's build and forget about it. But in the case of explainability, the need for continual enhancements and continual upgrades to the user-facing side is also important. And third is more of practice in the user sense, learning about the model, learning about what how things could have worked out, and learning how how the engineers may have developed this in order to serve the user's my needs. That is also important in the grand scheme of this. So it is both sides need to participate in order to get this job done. So just as a brief, these are the main components of explainable AI, and now move to a couple of just brief topics before we get to this example in healthcare. Um, just as an aside, we have um, modern services where AI is prevalent and existing. There's smart restaurants and bars. We're now able to have a robot mix a drink from a martini to serve you a Coke, or we can have robots that pick up silverware and dishes off of a table so that you can have contact-free service. Cybersecurity and fraud detection are becoming very large in this area. Systems diagnosis, we have intelligent bots like on Kaggle. Kaggle is able to automatically generate snippets of Python code, for example, that may give a user a good starting point if they want to start on a project with a data set that they're new to, where you may have to spend several hours getting started. Kaggle is able to give you maybe that first hour or first 20 or 30 minutes of insight right away, just based on a bot going through the information and going through the typical things that a user may want to do. We have adversaries in games. Many of people have heard about AlphaGo. There's also, again, 3D adversaries in games such as World of Warcraft or The Witcher. There's image tagging and picture enhancing. A lot of people are familiar with the amazing quality that smartphones have nowadays, and this is no short. This is no sort of miracle. This is something that has taken a lot of time and effort not just from a hardware perspective, but also from a software and artificial intelligence perspective. So, with these topics nailed down, we have the topic of artificial intelligence in healthcare, an example of AI as a modern facilitator. So, up till now, we've mostly discussed pretty general things. We have explainable AI as the goal, trying to nail down the box of what's going on inside the model for a user who isn't necessarily an engineer or who isn't necessarily highly proficient or technical in terms of statistics and artificial intelligence. Um, we have many application domains where this is relevant. Um, Autonomous cars, government will follow with healthcare, gaming, and many other places. And so these are kind of the backgrounds on these, and we'll go a little bit more into detail here with artificial intelligence in healthcare. So first topic is artificial intelligence in radiology. Much of the work here is done in imaging. Um, it's not just with photography. Oftentimes, since radiology is using more complex methods, there's CT scans, MRIs, and ultrasounds. These can be applied in many different ways to to perform colonoscopies or mammographs, brain imaging, um, thoracic imaging. All of these different forms of media come in to a system, and they're all processed in different ways, but they have their similarities. And a different one is radiomics. This is something, for example, that may be seen in an X-ray of the lungs, but because of the visibility of X-rays or the visibility in an MRI, it's not something that a technician or a radiologist might be able to see with the naked eye. But because of where we're going with technology, and because of the ability of so much data being processed and collected and available today, these features in radiomics can be captured and utilized, which is something almost in a sense superhuman, because without this information, or without a system that can comprehend this, the human eye would not be able to. And then we also have a third part in radiology called driver assist, which is mostly named from autonomous driving. Can also be called decision supporting, where a radiologist may have several scans coming in, may have a CT scan, an MRI, an ultrasound from three different patients, and they all come at the same time, and it's going to take, it's not instantaneous to determine the results. So a system in between may be able to initially capture or initially prioritize the needs of each individual based on their severity. Um, so second, we have artificial intelligence in cardiology. Um, Cardiology is becoming very adapted in two very enterprise related businesses. One being smartwatches. We have Fitbits and Apple Watches and Samsung Watches, and there's also in smartphones. People are able to take their heart rates through, or take an ECG on one of these devices, and for atrial fibrosis. And this is quite a lot of information that can be captured just by something that you have with you all day. We're also able to use smart scales and blood pressure cuffs that transmit information wirelessly. We have computer aided diagnosis, or CAD, which is able to perform near expert and fast identification of certain conditions. Um, Here, there's a little bit of a caveat. Here's a negative or kind of bad example of when AI does not always fit the need for what's going on in a relevant and real time environment. IBM Watson, which I'm sure many have heard of, has produced a system or an API service for cancer diagnosis, and everything was going well. Training and testing went very well. I believe the original paper cited values of like 96% accuracy. But when the actual model was implemented in the real world, there were things that the model didn't account for. There were things that didn't go just as well as everyone at IBM expected, and results were between 50 and 60%, depending on who was critiquing this model particularly. And what this does, and going back to the explainability, what this does is it scares people from the ability of artificial intelligence in our society, because cancer is cancer is a very serious and severe condition, and a model that is recommending chemotherapy to a patient who's totally fine and never had any history of cancer-related issues or no cancer in their family is a very scary and ominous thing to accidentally occur because of a system being misinformed. Um, this is obviously the type of thing that we need explainability for. Um, but moving on, we have more things in cardiology, a little bit more specific here. We have unsupervised methods to determine coronary artery disease by subtyping. We have prediction of cardiovascular event risks. We have the detection of 17 types of heart rate variability. We have the ability of subtyping type 2 diabetes. We have cardiac imaging, similar to the radiology, except these are a little bit more related to the heart. There is prediction of heart disease from heart rate variability and survival period after a heart attack for different time periods. What you can see on the right of all of these in parentheses is the type of model that was used to perform these from the references at the end. What you'll see is that if you're familiar with learning models, is that most, if not all of these, except for decision trees, are very convoluted in their nature and very, very difficult to explain. The reason these were included was because these were the at least leading at the time models for all of these categories and predictions and uh, models. So it's very clear to see that what we're doing now is using the best tools that we have to solve our hardest problems, but a step back in the direction of explainability might mean most of these models can't be used, or many of these models will need to be simplified. For example, in the case of deep learning, using convolutions is not a very complex method, but having several stacked layers and several um, dense layers for prediction and stacking all of these things together creates a very convoluted model that is very difficult to comprehend. The third topic here is artificial intelligence in healthcare systems. Um, this is more related to the information processing, not necessarily the actual uh, immediate direct care of the patient. A lot of the times, there's a lot of information coming from different sources. Patient data is growing at a speed that is blazing fast and very hard to understand with all of these different sources. The case example here is if you go into a clinic and you get some blood work done and you see your physician, and your physician recommends you to a specialist and you need to go through all these things. Um, all of these information sources are going to be gathered and collected in separate places, but an expert system that is able to handle all of these input and output sources of information would should easily combine and sort and populate information in the correct places using simple methods and simple models to optimize and compromise on information that needs to be generated and populated. There's also patient engagement and adherence. Every individual that walks into a clinic or facility is going to have different needs. Um, Sometimes these are chronic, sometimes these are acute needs, and they may need to be handled differently. We also have robot assisted surgery. We have analysis and summarization of clinical notes. We have resource tracking and utilization for issues such as masks in the COVID-19 pandemic. One example is maybe a network of hospitals has excess in masks or sterilization that they could share with their within their organization to a different facility when in a time of need, it may be hard to contact the provider to get these. So where are we going? Um, the future is bright, um, but there's a lot of opportunity that may be out there and not so well in compliance. Uh, we we some of the key ones being complete autonomy in surgery, having a robot do entire surgery from beginning to end, full drug design and creation, genomics and automated imaging diagnosis, or a couple more. Again, there's a lot of companies that are beginning this process of fruitful artificial intelligence in healthcare, but there's a lot of adherence that needs to go into this as people's personal information and private information is getting used by more and more private organizations or public organizations that may not be following all of these important rules related to HIPAA and things of this nature. Um, Continuation of this. So we have more tools every day. We have more systems every day, and this is leading to more discovery and ultimately leading to more data. We have a rising number of services that are being provided. Some of these are, or I should say, many of these are mostly disjoint. Going back to that hospital example of seeing a clinician and then seeing a specialist and then getting your blood work done. Patient care is moving from the clinic to the home for continuous monitoring. And again, going back to the topic of explainability, less is being understood overall. And the graph on the right, you can see um, the complexity or the explainability in terms of the model with relationship to the prediction accuracy. And as you can see, deep learning and SVMs are very, very high on this predictability or accuracy metric, but very, very low on the explainability metric. And this is where essentially we need to move forward. And with all these services and all this information being collected, there must be a move in the direction of explainability. Otherwise, we will have incredibly accurate models with no one being able to understand what's going on. And in a sense, the issue is we shouldn't be requiring an individual user to have extreme background in differential calculus or um, linear algebra to be able to use a device that has a simple model that will predict or not predict whether or not a patient has cancer. So, some more conclusions about where we're going. Um, in general, there is growing concern for the use of artificial intelligence in this area. Government officials are increasingly paying attention to this. Regulation and oversight almost appears just a matter of time for how artificial intelligence will be used. Explainable systems are becoming the cornerstone for latest technologies. It is almost essential nowadays that a artificial intelligence or smart system is adapted in any case to form or to handle many of the processes in a big data society like we are in now. And internally, the scientific community is now beginning to see the issues with having a very successful model that is poorly explainable, um, to the point where it could be almost considered embarrassing when someone asks you to explain uh, to a user why or why not a model will do what it just did. Um, and so we go back to the original question of how do we get um, how did we get explainable artificial intelligence as our modern facilitator? And this is just a natural, I think, in my opinion, a natural conclusion to the state we're at with so much information and big data being generated all the time around us, with more methods for understanding what diseases we have, for understanding what kind of games we want to play, and what kind of robots we want to have around our houses, whether it's a Roomba or a martini maker. There's just more information being created all the time, and artificial intelligence is right there at the middle, handling all of these amazing and beautiful things that we're creating. But again, the question of can artificial intelligence be appropriate, or can it be in a sense good? And my conclusion from going through all of these things is that in many cases it's up to the user who's creating and or the engineer who's creating and the user who's using to share a common goal of how the tool will be used, because everyone can hurt themselves with a hammer, but the person who creates the hammer and the person who uses the hammer, they both have the intention of striking a nail. So at the end of the day, the goal is to use the tool in the correct way. Of course, there are biases all the time. For example, smartphone cameras always have a difficult time detecting darker skinned people. And that's just a bias that is incorporated in the hardware and the software. And users need to understand that limitation, and engineers are obviously working on that limitation. Um, but in general, the ability to to have good artificial intelligence um, as a facilitator is really up to the individuals. Is mainly up to us. It's mainly up to me, and it's mainly up to you. So, in conclusion, artificial intelligence is definitely here to stay. It's made waves on almost every ecosystem or business. We're seeing a lot of adoption in terms of artificial intelligence, but we're relying on um, very weak methods to explain what's going on and why things are being decided the way they are. We don't have really very much control in this matter. We have some models such as decision trees, which are much easier to explain because they're just a matter of using formal logic, which can be explained using Venn diagrams and tools that more people are comfortable with. But we have a lot of difficulty with these kind of black box methods. We know that future explainability is going to cost a lot, or at least require a lot of effort. Um, we hope that it's adopted rapidly, just like unit testing in software development. It's a necessary evil, but it is something that is important and something that must be included. Otherwise, our ability to succeed as engineers in this space will be compromised. And that's mostly all for this presentation. Here are my references. All of the pictures I had were either from Google Images or the referenced works. Thank you very much.